Hello, class, and welcome to part 3 of Earth's Dimensions and Navigation. Today we'll be going to go over latitude and longitude. So how do we determine the exact locations on the Earth's surface? Okay, we use a thing called a coordinate system, okay, and it seems like a bunch of you guys already know about this. It's a grid where each location is defined by an intersection of two lines. And the coordinate system used on Earth is latitude and longitude. Notice how latitude comes first. Okay. But first we need to review the compass directions. We have north, south, west, east, northwest, northeast, southeast, and southwest. These directions will be important, especially when we get to our meteorology unit and we're looking at which way systems are going, or when we're looking at plate tectonics to see which way their plates are moving. Now, always look for a compass direction indicated on your map. Okay, it's usually in the bottom corner. So the North Pole is always towards north is always toward the North Pole. Okay, if you stand facing North Pole, east will be to your right, west will be to your left, and the south will be behind you. If we're standing in Hyde Park, okay, and we're looking towards Albany, we're looking to the north. So if we're looking to the north, New York City would be to our south. Connecticut would be to our east. And New Paltz would be to our west. The term due means directly. For example, north means directly north. How is latitude measured? The definition of latitude is the angular distance measured in degrees of a location north or south of the equator. The way I remember this is that it looks like the rungs of a ladder as you climb up. The red lines are the latitude lines. Now, notice that they are parallel to each other. Remember, parallel lines do not touch each other at all or intersect. How is latitude measured? The lines of latitude of a parallel circle that run east to west around the Earth. And we have important lines of latitude, such as the equator, the North Pole, and the South Pole. Here's a view from the equator. So if we're looking at it from the side, and if we're up above the North Pole and we're looking down, okay, it looks like a bullseye. Important lines of latitude. Our lowest latitude is 0 degrees, which means no direction, not north or south, okay? And it's also known as the equator. Okay, and it runs across our globe as such. Okay, here's a picture in Ecuador, okay, of where we're at 0 degrees latitude. Other important latitudes would be the highest latitudes of the North Pole and the South Pole. Our North Pole latitude is at 90 degrees north, and our lowest in the south would be 90 degrees south. 90 degrees is a right angle, if you remember that. So when we look at our map here, okay, there's some other important ones, such as the Arctic Circle and the Tropic of Cancer, Tropic of Capricorn, the Antarctic Circle, but we'll get to those later on. We're only concerned about the South Pole, North Pole, and the equator. Remember, the equator is 0 degrees north, North Pole is 90 degrees north, and South Pole is 90 degrees south. So how is latitude measured? If the equator separates the Earth into two hemispheres, okay, the northern hemisphere is the half of the Earth from the equator to the North Pole. Okay, it's the top part. And we use degrees north to indicate that. So the entire United States is north of the equator. And if you looked at Long Island, okay, its latitude would be 41 degrees north. Hyde Park is 42 degrees north. The southern hemisphere is the half of the Earth of the equator to the South Pole. Okay, everything below the equator. So here's our equator line. Everything above it is to the north. Everything below it is to the south. Now, is actually, okay, this map is just indicating where we see land. Okay, there is equal amounts of land of space above the equator and below the equator. How is longitude measured? Longitude is the angular distance measured in degrees going east or west from the prime meridian. Another way for saying east is to the right and west is to the left. Okay, and what's this prime meridian? The prime meridian is a line like the equator, okay, of where it's 0 degrees. Okay. Now, lines of longitude, okay, they're semicircles that run from one pole to another pole directly north or south. So in this picture, notice how it goes from the North Pole all the way to the South Pole, and that they intersect at the poles. So the space between at the poles is smaller than it is at the equator. And here is a view, okay, looks like an orange peel, and then from the top here, okay, it looks like a tire wheel where they're all intersecting at the center. Important lines of longitudes. We have a prime meridian. Okay, it's 0 degrees, not east or west, just 0 degrees. And the line of longitude that passes, this prime meridian, okay, is a line that goes through the city of Greenwich, England. Okay, and this was chosen by international agreement. We figured that we need to find a location that would be 0 degrees longitude, and it was agreed that Greenwich, England would be the location. And then on the other side of the Earth, we have our international date line. It's 180 degrees. Remember, half of a circle is 180. Okay, and there's no direction here at all either. Okay, it's just 180 degrees. There's 179 degrees west on one side and 179 degrees east on the other. Okay, and this is where a new day begins. So if we looked at our map, okay, and how longitude is measured, we can see the prime meridian on the right-hand side here. Okay, it's a straight line that goes up or down. And then we have all these different color codes that go across. These are time zones, and that'll be our last part of this, our last lesson in this unit. Then we have our international date line. The international date line is a little squiggly because there's certain islands and land features that people want to be located within the same time zone. So that's why it changes as it goes down through from the poles. Here's a marker in Greenwich, England that indicates where the prime meridian is located. And then you can see on either side of it how far it is to, or how many degrees it is to each location. So the prime meridian and the international date line separate the Earth into two hemispheres. Okay, we have the Western Hemisphere. Okay, half of the Earth west of the prime meridian to the international date line. Okay, and its units are degrees west. Okay, so the entire United States is west of the prime meridian. If you remember before, when we were talking about lines of latitude, the United States is to the north. So we are in the northwest quadrant, okay, on the map. Okay. Here's our prime meridian. Okay, and everything in the eastern hemisphere is half of the Earth east of the prime meridian to the international date line. And those units are degrees east. So west is to the left, east is to the right. Okay, and these are measured in degrees, going from 0 all the way up to 180. Once it goes past 180, it starts going back down again until we get back to 0. So how do you read latitude and longitude on a map from a point on a map? Okay, first we're going to write the units for each labeled angle, okay, if it is not already labeled. Okay, so if it's north of the equator, we're going to have degrees north. If it's south of the equator, we'll have degrees south. After that, we'll do our lines of longitude. If it's west of the prime meridian, we'll use degrees west, as long as it's up to 180 degrees. Okay, and if it's east of the prime meridian, we'll do degrees east. There is no direction for the equator, prime meridian, or the international date line, just degrees. Okay, remember the equator and the prime meridian are 0 degrees, and the international date line is 180 degrees. How do you read latitude and longitude from a point on a map? First, you're going to determine the latitude of the point. Okay, write the value of the correct units. Then you're going to determine the longitude of the point. write the value of the correct units. Remember, we're going to put latitude before longitude. Okay? So you must be able to determine latitude and longitude of locations in New York State. Okay, and this is on page 3 of your Earth Science reference tables. And around the world, which you use page 4 and page 5. Here's page 4. Okay, this shows our surface ocean currents. Okay, you can see all this. Then we have our lines of our equator. Everything above us to the north. Everything below us to the south. We have our prime meridian. The prime meridian, everything to the west, in their international date line. Everything to the west of the prime meridian, or to the left of the prime meridian, is to the west. Everything to the right is east. Now notice how it looks like it was cut off, and the Earth is continuous going around. Okay, we just want to emphasize North America in the center of this map. Okay, so there's only about 20 degrees east on the right-hand side, and then it continues with 20 degrees east, okay, on the left side of the map. Okay, and then here, notice how all of North America is north of the equator and west of the prime meridian. On page 5, we have our tectonic plates map. We have our equator drawn, everything above us to the north, everything below us to the south. Our prime meridian, everything in our international date line. Everything to the left of the prime meridian is to the west. Everything to the right of the prime meridian is east. Okay, and this has the same longitudinal issues that we saw on page 4, of where it goes from 0 to 20 east, and then it continues 20 to 180 on the left-hand side of the map. Okay, and there's North America again, which is in the northwest quadrant. On page 3 of our reference tables, okay, we have our New York State map. And you'll notice the coordinates as we go through this. So the numbers in the 40s along the sides, okay, show latitude in degrees north. Okay, I'm going to put these with a red line going across them all. You can see as we start at 41 degrees north, okay, near Long Island, goes to 42, 43, 44, and then 45 all at the top near Canada. Okay, that's our northern border of New York State. When we look at the halfway marks, okay, there's little dash lines that shows we're 44.5 degrees north, 43.5 degrees north, 42.5 degrees north, 41.5 degrees north, and then at the very bottom below Long Island, we have 40.5 degrees north. Our lines of longitude are in the 70s. And everything here is, notice how the latitude is to the north, longitude is to the west. We have 79 degrees west, 78 degrees west, 77 degrees west, 76 degrees west, 75 degrees west, 74 degrees west, and 73 degrees west. Okay, and then these also have halfway points as well as it goes across. So it makes a nice little graph or graph and grid square of New York State. And normally when we're in class, we would take out page 3 of our Earth Science reference tables, and we would draw these with colored pencils to help you guys. And we'll get that opportunity soon. For your checkpoint, you're going to determine the latitude of A, B, C, D, and X on the map below. Locate the letter, and then you're going to provide us with the numerical value of latitude and longitude in degrees. Okay, remember to put latitude first, longitude second. On the map, you'll see that we provide you with the equator, the prime meridian, and the international date line, along with the directions that will help you to identify whether in which quadrant it is, if it's north, south, east, or west.